Welcome to you all for showing up here. This is the most difficult moment of your of the entire conference. It's the day after the party, after lunch, but we'll try to keep it as pleasant as possible for you. This talk will be about software. Software is a meal best served with different architectural spices, in which we explore the limits of PowerPoint animation. But first, something about me. I am the architect. I have not always been an architect. I started as a junior software developer. And I worked very, very hard. And now, finally, I have become the architect. Thank you. Yes. This is the place I work. It's called the Ivory Tower. I work all the way at the top. Now, there have been some rumors recently, negative comments about architects working in Ivory Tower. Personally, I think it's a pity because I worked very hard to finally earn my place all the way on top, and now they say you shouldn't do that. I think it's just jealousy. But because the view on top is very spectacular, I can see all my software developers working very hard beneath me. The Ivory Tower has a restaurant. The restaurant has a chef. Does somebody know who this is? It's Nigella Lawson. Nigella Lawson works at my restaurant. And the other day, I come to the restaurant and I say, Nigella, I have a problem. And Nigella says, okay, what's your problem? And I say, there's something wrong with my architectural drawings. And she says, okay, that's a pity. Can you show me some of your architectural drawings? And I say, yes. This is an example of my web application. It's a web application server and a database. And here's an example of my mobile application solution. It's mobile app, backend, and database. This is an example of my IoT Industry 4.0 solution. It's IoT devices, application, and a Kafka cluster. And here's a solution, my solution for my digital transformation. It's enterprise data, Spark, and a data lake. And she looks at me in a rather strange, with a rather strange smile, and she says, okay, I see, and do you like them? And I say, yes, I like them because they fit perfectly. But I don't know, they're so boring and so pale. And I was clearly having an existential crisis because I said, perhaps I should do some real development work again, like fixing random failing tests on the CI/CD pipeline or solving indentation issues on my YAML files or learning Visual Studio Code shortcuts. She said, please don't. That's really for junior software developers to do. And I said, yes, indeed, thank you, Nigella, that's true. But what should I do? And Nigella said, when I was your age, I had the same problem. All my dishes look good, but they all contain the same thing: meat, vegetables, potatoes. Peas with steak and Belgian fries, pork, cauliflower, mashed potatoes, cordon bleu, carrots, broccoli, all good, but nothing really special. And then I met someone called Gordon Ramsay. And he said, you basically have two options. Either you go to a conference, a cooking conference, like Cook Stuff, or you go traveling. Traveling. Yes, that's what you should do. That's what I did. I traveled around the world, and everywhere I went, there was something I could take home with me. A recipe, a mixture of herbs, a spice, a crazy insect. After my travels, I returned home, and my dishes have become delicious. And now I have my own show at BBC. That's where I knew you from. Yes, and that's what you should do too. You should start traveling because, and then she said something very important, architectural styles are the ingredients that make your software spicy and tasty. I said, okay, Nigella, let's go. So I went to the nearest Gang of 4 train station and I jumped on the train. And the first place I went was called the Layered Mountains. Beautiful place, as you can see. And the Layered Mountains, they apply layered architecture. And it's really the granddaddy of all architectural styles. Basically what it means, separation of concerns. So if you have your bag of code, you separate your code into layers, ordering it from high to low. How do you know when you're high? If you're calling everyone else, you're high. If you're being called by everyone else, you're low. So you have your MVC layer with your controllers and your REST controllers. You have your application layer, you have your domain layer, and all the way at the bottom, you have your infrastructure layer. And the dependencies go from top to bottom. Why is that? If you separate them by layers, if you change something in one layer, it doesn't affect the other layers. All right, smart. So our source code of our application could look something like this. We have 4 projects, modules, whatever you want to call it: application, controller, domain, infrastructure. So what do we take away from this place? In our takeaway menu, we have separate code into layers, go from high to low, because a change inside one layer does not affect the others. There are lots of signs for additional walks in the layered mountains. One of them led me to this place, the inverted dependency peaks. Beautiful place on top of a mountain, as you can see. And at the top of the mountain, there was one man standing there, and he was standing there since 1984. And he said, "My name is Robert Martin, but you can call me Uncle Bob." So I said, "Yes, Uncle Bob, nice to meet you." And Uncle Bob invented the dependency inversion principle. Basically what it says, what he said is, high-level modules should not depend on low-level modules. Both should depend on abstractions. And abstractions shouldn't depend on details. Details should depend on abstractions. What I understand from this is that we should use interfaces. So if you have our picture from before, it now becomes something like this. Every layer has an implementation and an interface. And we depend on lower level interfaces instead of the implementation. All right. So our source code will look something like this. Every layer now has an API, or interfaces, and an implementation. What do we take away from this place? We use abstractions, and we depend on interfaces from lower levels. Okay, I spent enough time in the mountains, time to me to jump back on the train, and I went all the way to a place called Hexagonal City. Very crowded place. Lots of people there. One person I met there was called Alistair Cockburn, and he said, "I am here since 2005. And in addition, what he said was, you should not think of your application as layers. You should think of your application as a hexagon, with your application core in the middle, and at the periphery, you have something called ports and adapters. And you can think of your port as the interface and your adapter as the implementation. And for every integration point with the outside world, you have a port and adapter. For instance, a REST port and a SOAP port or messaging. But not only on the receiving side, also on the sync side, you have ports and adapters. One for your database, one for your emails, one for sending messages. Now, what's good about this is that you can swap your SQL into something else. Whoever changes a database once you write code, for instance, go from MySQL to Oracle, not a lot of people. But what you can do is if you write tests, you can swap it with an in-memory database, and you don't need a database at all for this then. Okay, another person I met there is Joey Palermo, who said in 2008, don't think of your application as hexagons. Think of your application as onions, and onions have layers, as Shrek told us. And inside of the onion, the core is your domain model. Outside is your application, and then at the periphery, you have your integration points. And the dependencies flow inward. And the hope is that if we change something else, if we need to integrate with another system, we only need to add another port and adapter, but our application and our domain logic stay shielded from those changes. All right, another person who was there was Uncle Bob. He came all the way from the mountains, all the way to Hexagonal City. And in 2012, he said, you should use clean architecture, which is basically more or less exactly the same, except we use entities instead of domain models, and we use use cases instead of application. Okay, enough time for me to spend in Hexagonal City. What do we take away? We have an isolated core and swappable implementations, for instance, for testing. Time for me to go to the next stop. The next stop was the service-oriented Emirates. The service-oriented Emirates, they apply service-oriented architecture. Basically, what it means is you have remotely callable components. And more or less, you associate SOA with SOAP and WSDL files, and that's basically how they use it. But it doesn't have to be. Basically, service-oriented architecture is based on 4 tenets. One is boundaries are explicit. What does that mean? That you cannot just call something without knowing that you're really calling the other service. You have to pass a boundary from one service to another service. 2, services are autonomous. They can be up, they can be down. If we have a service A calling service B, service A does not really know in advance if service B is up or down. They're autonomous. It can be version 1, it can be version 2, it can be no version at all, because there is no service B. Third, services share schema and contract, not class. What does that mean? Well, in SOA, it mostly meant we use XML, and we store our data in XML instead of just passing a class from service A to service B. And finally, service compatibility is based upon policy. Every service can express their capabilities. Now, SOA has a rather negative connotation now. I think probably because a lot of big software vendors promised a lot of dreams that did not really come through. But basically, SOA means we encapsulate behavior and state. And there's nothing wrong about that. And if we look at our canonical example of a web shop, we can see multiple services coming together into one page. We have our pricing service that gives us our price. We have our product catalog that we can search for all the available products. We have the shopping basket service. And we have the inventory service that knows if something is in stock or not. And if you want to know more about how to split your solution into different services, you should look at everything that Udi Dahan ever created on the internet, because that's basically what he's teaching us. So, our software project now looks like this. We have inventory, we have invoicing, we have order, we have product, separated vertically in services instead of horizontally. How do we do this? Well, every service can be a hexagon, like this. What do we take away from this place? Think of services instead of layers. And those services, they're autonomous. Now, from the service-oriented Emirates, it's only a small step to the holy land of microservices. And in the holy land of microservices, we use something called microservices, not services. And it's basically based upon 4 tenets. You have to pass a boundary. You share a schema and contract, not class. Services, microservices can be up or down. And something about compatibility. So indeed, microservices are almost the same as service-oriented architecture, but then a bit better. We learned a lot since service-oriented architecture. Actually, we learned so many things that there are a lot of advantages using microservices, like scalability improvements. We can use different technologies per service. One can be implemented in Python, the other in CGI bin. We can faster time to market. Yeah, I mean, you see those 3 dots. Basically, what it means is that the list of advantages of microservices is infinite, right? So what do we take away from this place? We use vertical silo boundaries instead of horizontal. Independent deployment of different microservices, and there's technology diversity that you can choose. Next stop, Restville. I arrived at the train station. I stepped out of the train, and I was a bit thirsty, so I went to the tourist office, and there was this woman behind the counter, and I asked, can I get a coffee somewhere here in Restville? And she glazed at me, but there was no response. So I looked above her head, was a big banner, and it said, get index. So I said, get index. And she replied me with a list of everything to do in Restville. Supermarkets, doctors, bakeries, butchers, including coffee shops. So I said, get coffee shops. And she gave me an entire list of all the available coffee shops, indexed by number. So I said, I just picked one, get coffee shops 5. And she gave me the directions to coffee shop 5. So I went there, I went to coffee shop 5. Turned out to be a Starbucks, who could have known. So I entered the Starbucks and I said, get coffee shops 5. No, I said, post coffee shops 5, order coffee. And the man behind the counter replied with a 202. It was accepted. What it also contained, the reply, was a link to that order. The order was 123. So then I said, get coffee shop 5, order 123. And I got a 204. No content. Okay. So I kept asking this every 10 seconds, get coffee shops 5, order 123, until finally my order was ready and I had my coffee. So what's happening in Restville, people speak Restish. Rest is an idea or a bunch of ideas thought about by Roy Fielding in 2000. And there's something called the REST maturity model. And basically what it means that if you don't use REST at all, you're really at level 0. That's why it's 0. And you use post for everything with some URL. And inside the body, it contains everything you need to know. The command you're sending, the data you need for your command. If you're using level 1, you start to use resources. You start to use URIs that point to a resource, like coffee shop 5, that's a resource. Starbucks, coffee shop 5, order 123, that's a resource. If you level up your game, you use level 2, you start to use those HTTP methods that have been created previously, like get, put, patch, delete, post. And those mean something. A get means you only get information, you're not changing the server. A post means, it can mean anything. A put means you're putting some state to some resource. And if you put it twice, the effect will be the same. If you go all the way to level 3, you start to use hypermedia controls and something called HTTPS. And what it basically means is, as a server, in your response, you're saying what the other options are. Where can you go from here? You ordered your coffee. Okay, I'm giving you a link to the coffee. Me, as the application, do not know in advance how should I query my order. I'm getting this from the response of the server. So the server guides the client in the different paths that are available. How do I implement this? Well, we had our hexagon. We just add a port and adapter, a REST port. Good, what do we take away? Let HTTP help you. HTTP has defined lots of things that the browser already implements. It's easy just to use that. Everything is stateless, which is a big point if you want to scale out your application. And the clients are unaware of the engine of application state, which is more or less a difficult way to express what I said previously. Next stop, final stop, the kingdom of events. In the kingdom of events, I stepped out of the train station and I saw this castle and I said, I want to visit this. So I approached the castle. There was a guard in front of the door, the gate, I should say. And immediately when I approached the gate, the guard said, "Visitor arriving." And as a response, the gate opened. I entered the gate. There was another guard at the other side of the castle, opening the gate. And once I entered, he said, "Visitor entered." And then the gate closed again. And what I saw inside the castle was very interesting, very busy place, lots of people. I had the castle keep in front of me, the kitchen to the left of me, the stables to the right, and there I was. And everyone was shouting events of things that they did. Things I heard were like, dishwasher activated, horse brushed, potatoes cooked, toilet paper insufficient, things like that. And everyone reacted to that. So what's really happening in the kingdom of events is they apply event-driven architecture. And in event-driven architecture, services or components or classes, whatever, they send events. Those are things that happened. For instance, when there's an order, the order component sends an ordered event. Invoicing listens to that ordered event and responds to that. The order component does not know who is listening to him, to his events or her events. Doesn't care, it just sends events. The shipping component also listens to the same ordered events to know that it needs to be shipping something. To whom? To the customer. How does he know the customer address? Well, because the customer service previously, lots and years before, already published another event telling the shipping service about the address. So that's the way they communicate. It's very logically decoupled. What do we take away from this place? Well, producers publish events, and producers don't know subscribers. All right? Okay, after lots of travels, it was time for me to go home, back to my ivory tower. And the first thing I did was look for Nigella. And I said, Nigella, from now on, all my applications will use microservices everywhere, using polyglot persistence, so every microservice can choose which database to use. And every communication will happen through events, orchestrated by RabbitMQ, of course. And in front of the microservice, we will have a backend for front-end, because otherwise the entire thing will not progress fast enough, and we will use OAuth 2 for security. And every microservice will use CQRS and event sourcing. Yes, with sagas for long-lived transactions and compensating actions. And all events will be stored in Kafka forever. Isn't that great? I was very excited. And Nigella looked at me, and she kind of looked different than previously. And I was getting a bit scared of her because I couldn't figure out if it was a knife she was holding or a banana. But basically what she said was, oh, I think they must have forgotten to learn you something very important in that ivory tower school of yours. And she continued. What do all these architectural styles have in common? And I said, she said, yes, come on, you can do this. What do all these styles try to achieve? Anyone? Yeah, could be, yeah. No. Yes! High cohesion and low coupling. Indeed. Coupling and cohesion. Cohesion refers to the degree to which elements inside the module belong to each other. Coupling refers to the interdependencies between modules. And so in general, we try to achieve high cohesion and low coupling. How do we do that? Layered architecture. We try to achieve high cohesion inside a layer. Dependency inversion principle. Try to achieve low coupling between layers. Hexagonal architecture. Try to achieve decoupling your endpoints from your application core. SOA tries to achieve decoupling between services. Microservice, decoupling between services, but then better. REST tries to decouple your backend from your frontend. And event-driven architecture tries to decouple your producers from your subscribers. Now, she said, what you have to understand is with every architectural style, you win some, but you also lose some. In the end, the only thing that really matters is working software. Architectural styles are just a means to an end. For instance, those three patterns are all about how to structure your code into layers or stuff like that. So I can, if I have my application, I can divide it into layers, but it might make more sense to divide it into vertical slices, because if I have to make a change here in my application layer, I probably also need to change the MVC layer. What you end up is lots and lots of modules. You have your different vertical slices, and then it's sliced horizontally, and then you have an implementation and an API. What I lose is the overview of how everything fits together. And there's also always some piece of code that doesn't really fit anywhere. So then you can either put it in some layer where it doesn't really belong, or you can add another module, and then you have even more modules. So that's what I lose. If we look at service decomposition, I told you about the advantages of microservices with 3 dots. It's true, there are lots and lots of advantages, but what you also get for free is just distributed log files. You have to start thinking about that. Didn't have that problem before, now I do. Service versioning, service A is talking to service B, version 1. Now, certainly, a version 2 is deployed. Is that still compatible? You have to think about backend and forward compatibility. Networking problems. Service A is talking to service B. Is it live? Is it the network? We don't know. And the nastiest of them all, DNS problems. We have to start thinking about startup synchronization. Service B is live, but is it ready? Is it still doing something? Is it populating a cache, or can it already work? We have to think about security, not only in one place, but at every service. We have to think about transactions. Transactions are assets. Transactions are out of the way once you start using microservices. So you do things like the outbox pattern. We have to make sure that the commands are handled idempotent. Didn't have that problem before. You have to think about a circuit breaker. Service B is down. Lots of services are calling that service, and now it gets up again and it gets pounded by everything and it goes down again. So before you know it, you have something like this if you're not prepared to that. A complete explosion of your application. While at the same time, There's nothing wrong with a majestic monolith. It's beautiful. As Simon Brown says, if you can't build a modular monolith, what makes you think microservices is the answer? It's a good way to go, sometimes. If we look at REST, we had the maturity model, and Roy Fielding really says, if you don't use level 3, it's not really REST. And he's right. That's the whole point, level 3. But why should I invest all this time in level 3 if there's only one client in my one front end for my back end? Doesn't make sense. I can just use like this, level 2. It's not REST. It's REST-like, but it's not REST. But that's okay. It works. Event-driven architecture. I can decouple my ordering service from my invoicing service, and that's just great. Sometimes I need to decouple. What I lose is the overview of how everything works together. If I look at my application that is entirely written using event-driven architecture, all I see is choreography. Everything's dancing and moving, but I don't know who's conducting because there is no conductor. Sometimes we just have an orchestrator that says, okay, you placed an order, invoicing, you start invoicing, shipping, you start shipping. Sometimes that's just the right solution. So how do we choose what architectural pattern to use, how to use it? Should we slice our solution horizontally or vertically? That's a difficult question. Well, it's based on context. What is context? Well, it's based on your team experience. If your team has never used event sourcing before, it's pretty weird in the beginning. It's based on the customer. Some customers just want a classical solution or not up to some adventurous architectural solution. The life cycle of your application. If it's only live for half a year, it really doesn't matter. The available technology. A lot of companies say you should use Oracle and nothing else. The budget now versus budget later. Development time, if it needs to be ready next month or not. Legislation, GDPR. GDPR makes us think of different ways to handle solutions than before. And you see those 3 dots. Lots of things that fit in context. Now, that's the rational solution or the rational explanation. Personally, I think there's another explanation. I think those architectural patterns are decided by people. And people have preferences. And those preferences aren't always based on context or rational thoughts. Most of the time, it's like a feeling that you have. People use the context afterwards to explain why they made those decisions. But a lot of the time, it's based on preferences. And those preferences are based on values. And so, at this point of the presentation, I want your cooperation. I will put on my glasses. And I want you to raise your hand and show me 1 to 5 fingers, depending on how much you agree to a certain statement. Are you ready? Yes? I have to say, the answers don't really, there's no good answer. That's what I wanted to say. Okay. There we go. Dependency enforcement. I value the fact that dependency inversion principle is enforced by design so that the developer cannot cut corners. Yeah. Feature locality. I value the fact that everything that is needed to implement a feature sits in the same place. Separation of concerns. I value the fact that my code is clearly divided into separate concerns. uniformity. I value the fact that my code always uses the same structure. Code as a liability. I value the fact that I can get a feature done as direct as possible with as little code as possible. Purpose naming. I value the fact that the name represents what it's used for. Implementation naming. I value the fact that the name represents exactly what it does. Concise naming. I value the fact that the name is short. Bird's eye view. I value the fact that I have an overview of how everything fits together. Library independence. I value the fact that I do not directly depend on a library or framework. Encapsulation. I value the fact that I can keep details hidden from the outside. And finally, composition. I value the fact that I can compose different parts to make a bigger whole. Okay, I could go on, but I'm stopping here because that's all that I could come up with. But what you see, if you looked at the rest of the people in the room, is that people have different values that they have for different parts of your software. Because people are people. And I can have, I have highly respected colleagues that have very successful software projects that look, and their architecture looks completely different than mine. And how is that? Is that because they are right and I'm wrong, or I'm right and they're wrong? No, because they have different values. It's all considerations. And I forgot, how do you get those values? Well, I think it's because you have different experiences in the past. I've been burned by a lot of stuff. Or I'm just wired differently. I like bird's eye view, I like the overview. Some people don't really need it. So I think that's how you get those values. Right. Okay, we've explored the world. Actually, we didn't. We explored just a little piece. There are other parts of the world in architectural styles that we didn't explore. Like Actor Beach, or Pipes and Filterland, or Lambda Laguna, or Copacabana, or P2P Paradise. It's up to you. Please explore those patterns, look what they gain you, but also look what they give you, but also what you lose by applying them. It's good that you realize. Nigella Lawson says, architectural styles are the spices that make your software tasty. She really does. Last week, I went to the restaurant. I went to the kitchen. Nigella was there. She had something cooking in the oven. And she asked, will you join me for dinner? I said, yes. So she went to the oven, she opened the oven door, she pulled the tray out, she put the pot on the table, and she put the lid off. And I looked at it. And it was a stew. It had different ingredients, well balanced, full of flavor, and it tasted delicious. Thank you.